Hello and welcome to a video on Nature of the Roots Part 1, brought to you by the Answer series. Before we can start looking at the nature of the roots, we just need to be reminded about various things. A real number is any number that can be plotted on a number line, so it can be whole numbers, fractions, decimals, positives, negatives, zero. Any number that can go on a number line is a real number. Non-real numbers are square roots of negatives. So for instance, the square root of -1 is non-real. Rational numbers are numbers that can be expressed as an integer over an integer. In other words, 5 is rational because I can write it as 5 over 1. -2.5 is rational because I can write it as -5 over 2. So any number that can be expressed as an integer over an integer, on condition that the denominator is not 0, is a rational number. An irrational number is a number that cannot be expressed as an integer over an integer. So something like the square root of 2 or pi. So it's very important that you know real and non-real numbers and rational and irrational numbers. With nature of the roots, what happens there is you don't want to know what the actual answers are. You want to know what kind of answers you're going to get. In other words, what is the type of number that the roots are? Are they real or non-real? Are they rational or irrational? And you also want to know how many there are. Are there 2 roots to the quadratic equation? Is there only 1 root? Or are there no real roots? So nature of the roots tells you what kind of answers you're going to get and how many you will get. In this question, you've been asked to solve for x using the quadratic formula. What I want you to do is I want you to literally use the quadratic formula, even though some of the answers can be solved by factors. But I want you to use the quadratic formula and I want you to show every step. And then once you've got your answers, I want you to look at each one and I want you to determine the nature of the roots. Are they real or non-real? Are they rational or irrational? Are you getting 2 solutions, 1 solution, or no solution? So pause this video, try these 4, and then we'll look at them together. In the first question, when you use the quadratic formula, you get that, and you get that x is 4 or 1. Both of those are real numbers, they're rational, and they are unequal. It's 2 different numbers you're getting. In 1.2, when I use the quadratic formula, I get that x is 0,85 or x is -2,35. Both of those numbers are real, they are irrational, and they are unequal. In 1.3, when I use the quadratic formula, you will notice that you get plus or minus root 0, which means if you take 6 plus 0 over 18 or 6 minus 0 over 18, you get exactly the same answer. So your roots are real, rational, and there were 2 answers because it was plus 0 or minus 0, but they both gave you exactly the same thing. In other words, the roots were equal. In 1.4, when I use the quadratic formula, you notice you get the square root of -11, which means there's no real solution, which means my roots are non-real. Now, what I want to do is I want to go back and I want to look at each of these very carefully and see which part of the quadratic formula is telling me what kinds of answers I'm going to get. And I'm going to start from the end. With 1.4, I get the square root of -11. I can't take the square root of -11 in the real number system, so that tells me that my roots are non-real. In 1.3, I got the square root of 0, and that told me that my roots were going to be equal, because whether I plus 0 or minus 0, my number doesn't change. In 1.2, I got the square root of 41. I needed a calculator to work that out, which told me that my roots were irrational. And in 1.1, I got the square root of 9, which meant I could get my answer without a calculator, and that's what told me my roots were rational. So in each case, what was under the square root sign is telling me the kinds of answers I'm getting and how many I'm getting. What is under the square root is b squared minus 4ac, and that we call delta, or the discriminant, and we represent it with a triangle. So in your quadratic formula, what is underneath the square root is very, very important. If delta is greater than or equal to 0, my roots will be real, because I can work out the square root of a positive number or 0. If delta is negative, my roots will be non-real. If delta is a perfect square, then I'll be able to work it out without using a calculator, and my roots will be rational. If delta is not a perfect square, my roots are irrational. If delta is equal to 0, my roots are equal. The two x values will be exactly the same. And if delta is not equal to 0, my roots are unequal. I can look at the same thing in a slightly different way. I take delta, which is b squared minus 4ac, and I see, is it greater than or equal to 0, or is it less than 0? If delta is less than 0, the roots are non-real, and you stop there. If delta is greater than or equal to 0, the roots are real, and I need to continue. I then see, is delta a perfect square, or is it not a perfect square? If it's not a perfect square, my roots are irrational and unequal. If delta is a perfect square, my roots are rational. And I keep going. I look to see if delta equals 0, or if it's not equal to 0. If it's not equal to 0, my roots are unequal. If it is equal to 0, my roots are equal. So whenever you're asked about the nature of the roots, you always work out delta, and then you go through the list, greater than or equal to 0, or less than 0. If it's greater than or equal to 0, keep going. Is it a perfect square, or isn't it a perfect square? If it is a perfect square, keep going. Is it equal to 0 or not equal to 0? So there you've got an idea of what happens when you are trying to determine the nature of the roots.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.